Hello and welcome to this engineering systems aspect of the data science course. In this course, we will have two different sections. One section is the algorithmic section where we try to understand the math behind data science, and in these sessions we will look at the engineering aspect of it. How do you actually build a system that you can deploy? Even within this section, we will have two different kinds of sessions. One like today, where I use the slides to explain to you some conceptual ideas, and in most other sessions we will actually do programming. So you will find me sitting with the system here and working with data science problems on real world data sets and explaining some of the interesting ideas as we go along building those systems. Okay, so I've been using the word systems very often. Let us try to formally understand what that means. In particular, what is systems thinking? Actually, if you go to the research pages of many computer science departments, for instance, take the example of IIT Madras, you would find that one set of faculty members work on systems engineering. In fact, in many other disciplines, also people talk about a systems track to their work. So what do they really mean? In day-to-day language, we use words like, I am doing this systematically. What we typically mean there is I am following some procedure. I am looking at the thing in a structured way and then doing it. So this is our day-to-day understanding of the word system. But here is one potential formal definition. Systems thinking is a way of thinking that is global and encompassing rather than focused on particular issues. Here the diagram as well shows, even if you are building a small part of a large system, it is important that you have in mind what the larger context is, and doing this is systems thinking. Let us take an example. Consider you are building a sorting algorithm, an algorithm that takes a bunch of numbers and rearranges them, let us say, in increasing order. Now, you might have studied something like bubble sort in your computer science courses as one very standard simple way of doing this. It turns out that though this is a good algorithm, if you implement it on a hardware is some processor that is actually going to implement it, these processors have what are called caches. Caches are a way to ensure that the memory access is more efficient. It turns out that bubble sort does not take advantage of the caching system we typically have. On the other hand, another algorithm called quick sort is much faster considering caching. So if I'm just an algorithm builder and I just make my algorithm, I might make bubble sort and be happy with that. But if I do systems thinking, if I try to ask the question, what is the broader context for this sorting algorithm, I might realize that quick sort is a better algorithm to choose. So this is really the essence of systems thinking. Find the bigger context and then build and make choices around the design that we are building. Okay. So this I think should be clear by now. Let us try to apply this to data science. So if you are trying to engineer a system for data science, the first question should be, what is this bigger encompassing global view? Clearly data science involves data. That is the raw material for data science. But what else is there? How do you fill in these blanks? What other components go to engineer a bigger system in data science? Please pause the video here and try to think of potential answers to fill in these blanks.